So now we're going to get some practice of plotting a quadratic production function. So here it is at the top. And I'm going to ask you to do a slightly simpler version of this. So let's just see how this goes. So we need to find each value of q, which is output for every value of k. So I've done a little table of values to help me, but you don't need to do that. You can just stick this into your calculator, substitute each new version of k into that. So I'm going to do it in stages, 3k and then k squared, quarter k squared, and then put it together to get the actual q value. So if k is 1, 3k is 3, k squared is 1, a quarter k squared is 0.25, and so that means the value of q is going to be 3k minus that, which is 2.75. So I've now got a pair of coordinates to plot. So let's quickly do the rest of them. So that's going to be 6, and 4, and a quarter of 4 is 1, and that's going to be k. 6 minus 1 is 5. 3k minus a quarter k squared is 5. So you see each of these is going to be that minus that. So we have 9. 3 squared is 9. Quarter is 2.5. And then subtract that from that, we're going to get 6.75. 4k will be 12. If k is 4, 3k is 12. K squared is going to be 16. A quarter k squared is 4. And 12 minus 4 is going to be 8. So 3k is 15. K squared is 25. Quarter k squared is 6.25. which gives me 8.75 when I subtract that from that. And finally, we're going to have 3k is 18, k squared is 36, quarter k squared is 9. Subtract that from that, we get 9. And I think I might just go over the top, literally over the top, as it's a quadratic. And we just put these numbers in: 21, 49, 12.25, 8.75. Hopefully this is still on the screen. Unfortunately, I don't get to see what's on the screen. Adequacy of the recording software I'm using. Okay, so let's plot these on our grid. So I'm plotting, well, actually, what I didn't put in the grid is 0, but if k is 0, this is going to be 0, so we know there's a point there. Goes nicely through the origin. And then I'm plotting k equals 1 against output of 2.75. So it's 1, 2.75 up there somewhere. When k is 2, output is 5. When k is 3, output is 6.75. 6.75, so about 3/4 of the way up that square. When k is 4, output is 8. When k is 5, output is 8.75. You see it's really tapering off now. When k is 6, output is 9. Now, we'd normally stop there. We wouldn't normally draw a production function further, but let's just see what it looks like. Here we are, being subversive here. When k is 7, q is 8.75. Actually, it's actually symmetrical, so that point is the same as that point. And then one last one, 8 against 8, which is symmetrical with that one. And it would just be completely symmetrical. So let's join that up and see what that looks like. So that's what we call a negative quadratic. It's a quadratic function because k is squared. It's negative because the sign of the k squared term is negative. So it's an upside down parabola. So that's what it looks like. So why don't we have a look now at the average product of capital ratios. So let's draw, not do all of them, let's just do this one and that one because they're nice and even numbers. So like we did in the other video, we are going to draw from the origin to the point k is 2 and output is 5. So that's here. So here's the first line. Then I'm going to do the same for when k is 4. So here's this one. And you see the gradient is getting shallower because the average is going down. And 6 and 9. 6 and 9. So here's another line. Well, I suppose we could do this one as well. And 8 to 8. Here it is. Really shallow there. Now remember, the gradients of these lines represent the average output per unit of capital this time. It was workers last time. So how do we find the gradient of this? Well, it's this dimension, which is 5 divided by 2. So 5 divided by 2 is going to give us 2.5. So the average output for every unit of capital here is 5 divided by 2. So that's at its best. Now when we come to this line here, we're dividing 8 by 4. So every unit of capital is getting us 2 units of output. So you see it's coming down. What happens when we get to 6? Now we've got 9. I could write it here actually. 9 divided by 6, 8 divided by 4, 5 divided by 2. 9 divided by 6 is what? 1.5. And let's just do it. So what is it here? By the time we get to this one, we've got 8 units of output for 8 units of capital. So the average product of capital has gone down to 1. So this is what we expect with diminishing returns to capital. So we get a lot more out of every extra unit of capital here, but it starts to slow down. Now, we don't normally show this going over the top, because what this is telling us is that if we put 8 units of capital, we actually get less out than we do, say, for 4, because that point's lower than that. We actually get less output for it. That doesn't usually happen. So we don't normally go. We normally stop it there, and I'm going to have you stop there on the one that you're going to do. So there's our average product of capital. There's our quadratic graph. So this is the one I was going to ask you to do. Right, there it is. Here's the function, a little simpler than the other one. This will just go up to a peak and stop. So have a go at plotting this. Maybe just look at the APL or the APK line, sorry, it's capital, not labour this time, for these 3 points, when k is 1, k is 2, k is 3, and work out the gradient. Just draw those 3 lines, as it says there. And bring us along to the lecture on the 25th, and good luck.